Okay, today we will see about one more joining topic, which is self join. Self join. So, in the beginning, it is going to be a little difficult to understand this. So, what is a self join? Okay, the name itself says self join. Means joins are always used to join two different. You join usually you join two different tables. For example, in our previous classes, so we are using joins concepts, and we were almost dealing with what joining the data or joining the rows from one table to another table. If you take course table and the student table, at least more than one table is required, right? And we were dealing with employee table and department table, and we were dealing with something like employee table and sal grade table. So more than one table is required to use the joining concepts. No, this is what we have understood so far from our previous sessions, like cross join. Take the cross join as an example, or natural joins, or equi joins, non-equi joins. At least more than one table is required. Okay, and we were dealing with the test one table and test two table, right? And also we have discussed about items one table, items two table, right? So this was a requirement in our previous topics, right? We were dealing with two tables at least. Okay? But when it comes to self join, you are going to deal with only one table, right? If you take a table, like if you take a table like this, now this self join is like you will be dealing with only one table, right? You work on the same table. Let us say that the table name is T1. You're going to work on the same table to join two different rows. Okay, let us understand how it will work. By the name itself, I can say that self join. Joining a table by itself is called as self join. First point. I can say that please be informed that when you are joining a table by itself is called as self join. Okay. The second point says it can be implemented. Okay? It can be implemented on a single table only. Implemented on a single table only, right? So they have introduced a concept. See, this is going to work like this. If I ever had to help you with the real-time analogy, for example, let us take that there is a person. Okay, a physical person is there. There is a physical person. We want to identify himself. What he can do if the physical person wants to identify himself, or if you want to recognize his face, if you want to see how he looks, if you want to see how he walks, okay? If you want to see a kind of how he behaves physically, he just see himself in the mirror, right? He just stand in front of the mirror, right? When he stands in front of the mirror, usually what would happen? A virtual image will be created. Okay, the same person can see himself, isn't it? In the mirror, the same person can be seen in the mirror. But this is the physical person, the actual person, the person who is existed. Okay? And the person, the reflection. This reflection is called as what? The virtual image. Virtual image, but it doesn't mean that there are two physical persons. Only one physical person is there. Because of the mirror, his own image can be reflected in the mirror. So this is virtual. Whatever the actions that he's doing here, the same actions will be reflected in the mirror, right? Whatever the actions is done. But what is the help of the mirror according to this person? Okay, mirror is going to help him to identify himself, to identify how he looks, to do a kind of comparison, right? He can do not a comparison. He can actually see how no how he is looking actually, right? He cannot see himself, right? Can he see himself? He cannot see from his eyes. He cannot see his eyes. Through his eyes, he cannot see his own, nose, own mouth. Some parts are invisible to him that can be solved by using the mirror, right? The same thing is happening. The same thing is happening in the self join. When you take a self join, okay. So when you take a table, this table, if you are working on a self join, a reflection, okay, another table of the same type will be created. Okay, then you will start comparing. You will start comparing the actual rows from one table to another table. This is how you do the comparison. But the question is how to generate this virtual table from the existing table. How to generate the virtual table from where? From the existing table. That is a symbolic question, isn't it? Yes. Okay. So what usually we do, okay, to we generate what? We generate alias names. Alias names. Okay, with the help of alias names, you can generate n number of virtual tables. Right? For example, if I having a table, if I have a table like employee table. Okay. So if I am going to say employee space E1, okay, one virtual table is created. If I say employee space E2, okay, two virtual tables are created. If I say employee space E3, three virtual tables are created. These alias names are actually creating the virtual tables. You can create n number of virtual tables. You can do the joining operation. So this is the way you can understand, you can usually understand the joining operation. Right? These alias names are what? These alias names are going to be the backbone to to work on the self joins. Okay, what I can conclude here, we put it here. The third point. The third point says it can be implemented. Can be implemented with the help of alias names, and without alias names we cannot implement self joining technique. Okay, who is going to do this kind of operations? So we know, now we got to know the alias names are required, right? And internally the Oracle DB server will prepare a virtual table on each and every alias name. Okay, the moment you start creating alias names, okay, so the internally Oracle DB will take care. Okay, internally the Oracle DB will take care. So in this case I have generated three aliases, right? The aliases are what? E1 alias, E2 alias, and E3 alias. Okay. So internally will Oracle DB will come into the picture to do what? Okay. So once the alias names are created on a particular table, internally Oracle DB server will prepare what? It is going to prepare a virtual table on each alias name. Alias name. right? If I take this as the example, okay, so if I say that this is the employee table, okay, if I say that this is my employee table, actual the original employee table is my employee table. How many virtual table, how many aliases you have created? You have created E1, you have created E2, and you have created E3, right? For each and every alias, a virtual table will be created. This is going to be for E1, this is going to be for E2, and this is going to be for E3. Okay? So that you can comfortably implement what? You can comfortably implement the self-joins. You don't require additional table. You work on the same table to prepare the joining queries. Self-join, selfing. Three aliases, for three aliases, three virtual tables are created. Right? Physically, it is just like this. See, the same person example I have taken, right? Take one person. Okay, this one person, if he is seeing himself in one mirror, okay, it is very what? It is very much identical that he can see his virtual mirror in one mirror. Right? If I place another mirror, okay, behind him, two virtual images are created. If I place another mirror, over here, three virtual images are created. You place another mirror. How many mirrors you place? Okay, those many number of virtual images are going to be created for one physical person. This virtual, this alias names are also like this only. The alias names are also like this. So this is one virtual image. This is one another virtual image. This is another virtual image. But the actual physical person is only one person. Same analogy you can apply it for what? The employee table. The moment you start creating aliases, Oracle DB will start creating the virtual tables for each and every aliases. So by this I can conclude that you can create any number of alias names. Okay, you can create any number of alias names. Please be informed that you can create any number of alias names, but each name has to be different. Has to be different. Duplications are not allowed. Okay. One more point says, so self-join techniques can be used in two cases. So there are two cases where you can use the self-joins. Self-joins can be used in two cases. Case number one says comparing a single column value by itself within the same table. So in a table, right? So when you talk about the columns, so let us take this as an example. So this is my employee table, or this is my T1 table, whatever it is. Okay. And if I take a particular column, if I take this particular column, I want to work on this particular one column. So this is my column, right? So first thing is this column is going to have, in this case, there are three values this column is going to hold in each and every row, right? So you use one column, okay? You use one column, the values that are present inside one column. For example, let us say that, so there is a value here, there is a value here, there is a value here. The same column, I have three values. Right? I want to compare this value with this value. I want to do the comparison from this value to this value. Based upon the result, I want to join. I want to perform what? I want to perform the join operation. Let us say that if this comparison is completely, these two tables are getting compared and they are completely valid. So I will be joining these two rows, and the resultant row is going to be like. right? So a new row is going to get created, and the new row is going to have what, the six columns. This kind of operation is what called as what, join, by using one column, and if you compare the values, this is one of the ways to do this, to use the single joins. The first way, comparing a single column values by itself in the table. So this is what it is. The second one is comparing multiple columns values to each other within the table. Comparing multiple column values to each other in the single table, in the table. Multiple elements, you take more than one column and you do the comparison with each other within the same table. So these are the two things that you can do. We'll see one example to understand the basic functionality of this, basic functionality of this self joins. Okay. I want to take a simple example to understand this simple example. Right, I will create a table like a kind of okay, let me create a small table. Taking time to open. One minute, guys. Okay. MyDB 7 a.m. MyDB 7 a.m. User ID and the password. Sorry, I have given the wrong one. Okay, the connection has been established. I want to create a simple table. Create table. The name of the table is test table. Okay. So I'm taking two columns. One is the employee name column of varchar 2 type. Second one is the location column, which is also of varchar 2 type. It says the table is already exists. Let me drop that. Drop table test. Okay, the table has been dropped. A table is created by the name of test. I want to insert some values. Let me say insert into test values. Okay, let us say Suresh, comma, Mumbai. Location is Mumbai. Okay. Next one is Hyderabad. In Hyderabad, Ramesh is there. Okay. Let us say Vignesh Chennai Ganesh Hyderabad. So okay, I have inserted four rows. Okay, if you want to see this completely, select R from. Okay, this is the information that I have. I have one table with this many rows, right? So now I want to apply what I want to apply the self join. So self join is what I will be dealing with the same table. My query is going to be like, okay, what query that we can prefer here? Okay, let us say that I want to display employees who are working in the same location. Okay, the employee Ramesh is working. Okay, let me put the question here. Write a query to display employees who are working the same location of same location as Ramesh is working. Okay, here the question is not a straightforward question. Okay, I want to generate the list of employees. I want to generate list of employees who are working the same location. First, I want to find where this Ramesh is working. Okay, there is a question inside the question. First, I want to find where the Ramesh is working. Where he is working. Let us say that if he's working in X location, right? I want to map these employees who are also working this in S location. I want to map the employees. There are some employees, right? There will be employees who will be working the same as the location it is being on where is where Ramesh is also working. I want to find the list of employees. Okay, list of employees who is working as who is working same as where the Ramesh is working. For this, I have taken a simple table. The table is what? The test table. So this is information that I have taken, collected. Test table. I have a test table. Okay, by looking at the table, you know. Okay, without looking at the table, we don't know. By looking at the table, we know Ramesh is working in Hyderabad. Without looking at the table, we don't know if the Ramesh is working in Hyderabad or not. Right? So I want to get the answer what? I want to get the list of employees. Like answer should be what? Ramesh Hyderabad and Ganesh Hyderabad. Because remaining employees are not working in the Hyderabad location. Because Ramesh is working in Hyderabad, so I want to fetch all the employees who are working in Hyderabad location. Right? Firstly, what I will be doing, I will be writing a simple query, right? Let me okay. The query could be like select star from what name of the table is test. So what I'm supposed to do, I'm using the self join. So I need to create the virtual tables. To create the virtual tables, I need to use the alias names. Right? I'm saying test table name itself is test. Okay, I'm taking the alias name as t1. Okay, so join, the join key is join itself test t2, right? The condition is on t1 dot location equal to t2 dot location. Okay, so this is going to do something in the SQL server. This is going to do something in the SQL server. Okay, see how many, see if you look at these table names, table name is common, test is the common table name. So this is the alias t1 and this is another alias t2, right? So this is the actual table, test is the actual table. Let us say that this is the actual table. Okay, because I am using the alias name, a virtual table will be created for t1, right? Another virtual table will be created for t2. So this T1 is a virtual table and T2 is a virtual table. These tables are generated by what? Oracle DB server. The two virtual tables are created, right? And you are comparing the location. You are comparing the LOC from one virtual table to another virtual table. The LOC is the location, right? LOC is the location. So same location is compared. So behind the scenes, this is what happens. The same table is going to be compared with the same table. So this concept is called as what? This concept is called as the self joining. Join the same table, the same table. Join the same table with the same table. Right? And you do the comparison. So this is T1 and this one is T1 and this one is what? This one is T2. If I run this command, what would ideally happen behind the scenes? See, select star from test alias T1, okay, join test alias T2 on T1 dot LOC equal to T2 dot LOC, right? So two tables are joined on top of which condition? On top of the location LOC condition. On top of LOC condition, these two tables are joined. So this is what is happening behind the scenes. The same table is getting compared with the same table itself, right? So the comparison we know. From here the comparison will start. Okay, Mumbai. Location is Mumbai matching. So this record will be fetched. Then Mumbai, Hyderabad not matching, it not be fetched. Mumbai, Chennai not matching, it will not be fetched. Mumbai, Hyderabad not matching, it will not be fetched. Likewise, second one is what? Hyderabad, Mumbai not matching. Hyderabad matching will be fetched. Okay, Hyderabad, Chennai not matching. Hyderabad matching, it will be fetched. Right. The third one is if you apply all these combinations, right? Six rows are, how many rows are generated? In our case, 6 rows are generated if you apply all the combinations. Okay. Chennai, Mumbai, Chennai, Hyderabad, followed by Chennai matching. Okay, it will be, it will be attached, and the last one is what? Hyderabad, Mumbai, Hyderabad matching. Okay, it will be considered. Hyderabad, Chennai not matching. Hyderabad. So if you apply all the combinations, so you have what? You 6 set of rows are generated. How many columns? If you see number of columns, the number of columns are 4. Number of columns are based upon the actual columns in the given table. So you have 2 columns. If you apply the self joining technique, you get 4 columns. into 2. If you have 3 columns, you get 3 into 3. And also you are selecting all, isn't it here? Selecting all the columns. So all the columns are printed. But still my question is, I did not get answer to my question. Okay, what I'm doing it here. So what I'm saying, T1.loc equal to T2.loc. I'm going to add another condition, right? And I'm saying, check whether the ename is what? Ename is Ramesh. If the ename is Ramesh, I can able to map his location to this to this joining condition. Okay. Through this joining condition, I will be able to map the location of the Ramesh. This map location is going to fetch all the data, okay, where Ramesh is working. I'm going to get the location and I'm going to get the remaining employees who are also working in the other location. But there is a problem in this query. There's a big problem in this query. Okay, what is the problem? The problem is you are taking the ename, but you are not being very specific, because there are columns. There are 2 columns by the name ename. Which ename you are referring to? That confusion will be, that ambiguous situation will be encountered by what? Oracle SQL server. Which ename you are referring to? You have to be very specific now, because there are 2 enames, right? You have to be very specific. Since there are 2 enames, which ename you are specific referring to? I am referring to this ename. I am referring to this ename. So this is my reference. This is my what? This is my, how I can state that this is my reference. So this table is alias for what? This table is T2 alias. So this table is T1 alias. So if I am taking this ename as a reference, I need to use T2 dot ename. Right? Now there will be no confusion. If you execute this query, ename equal to what? Ename equal to Ramesh. So there is an ambiguous situation. It does not know which ename we are referring to. So now I am going to be very specific. I will be saying that the ename of table alias table T2. Okay, now I get information. If you see this information, right? So this query has given me this table, the new table. Again, there is a problem. So we are not expecting this, right? So this query is again giving me this information. Okay, but I do not want this information. I do not want this table. Because now if you see the T1 table, okay, it has given me the employees who is working in the Hyderabad, who is working in the location same as Ramesh. Ramesh is working in Hyderabad. Ganesh is also working in Hyderabad. Okay, but this is not what I want. This is not what I want. I want only this. So I do not want this. I do not want this. This is not what I am expecting. I do not want this. How I can modify my query? What are the things that I can add in my query? Right? Simply, I need to what? I need to make changes in my select statement. I need to make some change. I need to make some statement in my select statement. Instead of star, I need to make some other changes. I want what? I want only ename and LOC of the T1 alias table. Right? Simple modification I can do. Instead of using star, I can do what? I can remove this. I can say T1 dot ename comma, right, T2 dot LOC. Now I will get, so Ramesh location is Hyderabad, Ganesh is also working in Hyderabad. There is a lot of confusion, isn't it? How this has happened. Let me execute the internal things. Let me execute what? Let me execute the internal things. Let me copy this query. I will take this space as an example. Focus here. Okay. Focus each and every line. So this condition. Okay. So test T1 join test T2. So two tables are created, isn't it? So now I have two tables with me. So this is my table. Okay, two tables, T1 and T2. Okay, so this is T1. Okay, this is T2. Alias names are creating two virtual tables. The second thing is I have the table information. Right? Look at these. You are able to see this the joining condition, right? It says you're joining T1.loc equal to T2.loc, right? So you are specifically focusing upon which column? LOC column, right? T1 is focusing on LOC column. T2 is also focusing on LOC column. So the location column. Do you think so? We are focusing on which column? We are focusing on location column, right? And after this, so you are using the another condition, right? Another logical condition, which is what you're using this and operator. Okay, another logical condition is being used here, and operator is being used. This AND operation is going to check the second condition. The first condition is the location should be equal. It is Mumbai, it should be Mumbai. And also the second condition should be what? Whether the person is Ramesh or not. In the T2 table, whether the employee name is Ramesh or not. If these conditions are matching, then the rows will be, two rows will be joined. If not, this will not be joined. And so this AND operator condition is very important to get the actual results that we are expecting. Right? The next thing is ideally, what is the next thing that is happening ideally, right? So we know that, okay, this is going to do what? Okay, T1.loc equal to T2.loc. This the join queries will search each and every combinations, right? So Mumbai, so first row will be compared with the first row of the virtual table, right? So Mumbai matching, right? Mumbai first condition is matching, but there is a problem. What? First condition is matching. Mumbai is matching here. Location wise, it is matching, right? So this condition is matching, but followed by you are using the AND operator. You are saying T2.ename equal to Ramesh, but here the ename is what? Ename is Suresh. So it is not matching. So this data will not be retrieved, right? Likewise, from here, second row, Mumbai, Hyderabad comparison. Okay, first one itself is not matching, so it will not go for the second one, right? So very simple, guys. The first condition is the location comparison. Location is getting compared with what? With the name Ramesh. This Ramesh is of what T2 table. Okay. The first one, Mumbai, Hyderabad. Here, Mumbai, Hyderabad, not matching. So this will be ignored. First itself is false, so it will not go and check the second condition. Mumbai, Chennai. Again, it will not be because Mumbai, Chennai, both are different locations, right? And the fourth one is what? Mumbai, Hyderabad. Right? Both are what? Again, both are different locations. And let us see the second one. Second one is like Hyderabad, Mumbai. Locations are different, right? Then Hyderabad, Hyderabad, right? Locations are same. Okay. First condition is matching. So this is matching, right? This is matching. This is matching. It will check for the second condition, Ramesh. It will check whether the employee name is Ramesh. Okay. Employee name is also Ramesh, right? Then these two rows will be joined. What are these two rows? Okay, these two rows. Ramesh Hyderabad, Ramesh Hyderabad, Ramesh Hyderabad, Ramesh Hyderabad. Okay. Third one. These two rows will be compared, not matching, right? Hyderabad, Chennai, not matching. Right? And the last one is what? Hyderabad is matching. Hyderabad is matching. But if you see the name is not matching. Name is Ganesh. We are expecting Ramesh. That will be ignored. Right? The third one. Weakness. Chennai, Mumbai. Chennai, Mumbai. Not matching. Right? Next one is Chennai, Hyderabad. Not matching. Chennai, matching, but name is we are expecting Ramesh, but the name is weakness, not matching. Next one is uh, Chennai, Hyderabad, not matching. Okay, the last one, okay, last comparison. Hyderabad, Mumbai, not matching. Okay, Hyderabad, matching, right? But and also the name is also matched. The name is Ramesh here, right? So this row will be joined. Ganesh, Hyderabad, Ramesh, Hyderabad, right? And Hyderabad, Chennai not matching, right? Hyderabad matching, but the name is Ganesh. We are expecting Ramesh. That's why it will not be considered. Okay? If you say, so I got what I want, but something additional thing I have got. Okay? I have got what I want. You see, whatever I am expecting, I have got that. Right? But I am not looking for this. I am not looking for the second table, which is T. I am not looking for. I want to eliminate this. To eliminate this, I want to make changes exactly over here. That is what I have done here. I am specifically selecting. Okay, I have taken T1 here. It is not T1. It is T2. T1 dot in. Okay, it is T1 dot ename and T1 dot location. T1 dot ename and T1 dot ename. I want to select the table 1 alias. Ramesh Hyderabad, Ganesh Hyderabad. It should be T1, not T2, guys. This is T1. Yes, T1. Okay. So this will ensure that this is getting eliminated. Now result, if you see the result, we have got the Ramesh location, which is Hyderabad. Right? We have got the Ramesh location, which is Hyderabad. And Ganesh is also working in what? Ganesh is also working in Hyderabad. How this is achieved? With the help of self joiner, ideally it is actually with the help of this condition. This because this with the help of this condition. The second alias table, you are identifying the Ramesh, right? You want to join two rows based upon the employee name Ramesh. This permutation and combination is going to give us four columns. Okay, and it is also ideally including another person who is what? Who is Ganesh, who is also working in Hyderabad. Right, so this is helping us to achieve what we want exactly, the permutation and combinations. Right? In the future, okay, if you want to select an employee, okay, if you want to see instead of Ramesh, if I want to my query is something like this. I want to find the employee, I want to find who are working in the Chennai location, or I want to find the employee who are working in the location same as Vignesh. Okay, so I will be selecting t2.ename equal to, instead of Ramesh, I will be selecting Vignesh. So two alias tables has to be created, and when you do this kind of comparison, right, you will get the right answer. So with the one query, you will not get much thing. With the one query, we will understand how the self join is actually operating upon. Okay, if you work on multiple queries now, then the complete picture will be given. Okay, for example, okay, I want to take, okay, now I want to see, we have the employee table. Okay, let us go and see the employee table. Set a size 100, set lines 150, select star from EMP. So this is my employee table. Okay, right, I want to find something like, what else we can take it here. Okay, I want to find the salary of all employees who is getting the salary as Jain. See the Jain salary is 95,000. I want to find all the employees who is getting the same 95,000. Okay, how I can write this query? Write a query to display employees whose salary is same as the employee Jain. Right, so I need to create two aliases table. Okay, two virtual table, isn't it? Same thing I will do. Select star from, okay, this is employee table, EMP space E1, join EMP space E2, right, on condition on E1 dot sal equal to E2 dot sal. I will be using the salary column followed by it, and E2 dot this ename equal to Jain. Okay. Now instead of star, I will be selecting only two columns, which is what, E1 dot ename, comma, E1 dot Jain is 95,000, Emily is also 95,000. You just study this query, if you just observe this query, so this is same like our previous query, the same like our previous query. So you are using two conditions here. First one is the joining condition. You are joining two tables based upon the salary column, followed by you are adding another condition. Okay, this is the important condition. You are fetching the name of the employee, which is Jain. Right? Same like the previous query. So two identical tables will be created. okay? And every row will be compared with another row. But in the second virtual table, your condition is very specific. You are selecting the chain, selecting the name as chain. You apply all the permutations and internally, like not permutation combinations. You just observe the pattern, right? The on top of while the salary columns are while the salary rows are joined between two tables, you will also check whether the employee name is chain, right? So because of this query pattern, okay, the salary will be retrieved, and salary will be retrieved for all the employees who is getting salary same as chain. This condition is applied on the E2 table, okay, not on the E1 table. Okay, just practice this and try to understand the pattern, especially on this, right? Things will be clear. This is just an introduction about self join. Okay, you when you see a few more examples, okay, you become expert in this concept, right?